And welcome to today's Cosmology segment. We've decided to go live for this one. Let's get to it. And if you're viewing the videos only on BitChute, please go subscribe over on YouTube. You're missing like 80% of our content. This one was streamed live to Twitch. It's a fantastic fantastic live streaming platform. It also has a great mobile app. Check that out. We're also on BitChute. Did you see our video yesterday about naming conventions featuring one of our patrons, Donnie, as well as particle physicist Eugene Bagashov? Yeah, it's about naming conventions. Are they nonsense? Are they science? I'm not even going to play you a clip. You got to watch the video. youtube.com/smAsho/videos. You should find it in there. And let's break out today's Cosmology segment. So this is going to be a good one. That's why we had to make it into a separate video. Let's do it. Did you know that cosmic rays and supernovae are related? In that when a supernova occurs, the environment surrounding the star that goes nova affects the environment differently. If it's in a dense environment with lots of gas and dust, a lot of molecular material around it, it affects the environment differently than it does if it's in a more empty section of space. Seems to make a lot of sense, right? Anyway, here's an article about it. Cosmic rays help supernova explosions pack a bigger punch. So this is from phys.org and their astronomy and space section. I'll just let the article scroll here. Feel free to have a read, pause the video. We'll be here when you come back. So cosmic rays are primarily hydrogen nuclei traveling at relativistic speeds. And here's an image of a supernoval cloud. And this one is showing you high energy X-rays in blue, medium energy X-rays in green, and lower energy X-rays in red. And the mechanisms behind how this happens are not fully understood yet. However, we're working on getting them understood. When the supernova reaches a stage in which it cannot gain more momentum from the conversion of the supernova's thermal energy to kinetic energy, we found that the cosmic rays can give an extra push to the gas, allowing for the final momentum imparted to be 4 to 6 times higher than previously predicted. Contrary to state-of-the-art theoretical arguments, the simulations also suggest that the extra push provided by the cosmic rays is more significant when massive stars explode in low-density environments. This could facilitate the creation of superbubbles powered by successive generations of supernovae, sweeping gas from the interstellar medium and venting it out of galactic disks. Rodriguez Montero adds that, quote, results are a first look at the extraordinary new insights that cosmic rays will provide to our understanding of the complex nature of galaxy formation. So go have a read on phys.org in the astronomy and space section if you want to check that one out. Also, maybe check out the National Astronomy Meeting in Bath, which occurred yesterday. It's linked in the article as well. And how about some X-ray bursts from magnetar SJ? It's a soft gamma repeater. That's what SGR stands for. Soft gamma repeater. J1935 plus 2154. And so from data from NASA's Fermi spacecraft, some Chinese astronomers have been studying this soft gamma ray repeater located at about 30,000 light years distance. Again, I'm going to let this article scroll as well. There we go. Quote, given that there is no evidence showing SGR J1935 plus 2154 are a binary system, we focus on the explanations invoking the properties of the magnetar itself, as typically these sort of gamma ray emitting objects have their behavior blamed on being a binary system interacting with another star, etc. This one does not appear to be doing so, so perhaps once again it flies in the face of the sort of standard model of cosmology. This one is on the phys.org astronomy and space section as well. Next, the astronomy picture of the day, which is a nebular cloud created by a Wolf-Rayet star. So the star at the center of this image here is a Wolf-Rayet star. So this is something that we're very interested in, as The star we talk about all the time, Deneb, involves a Wolf-Rayet star and an allegedly even more massive object orbiting it at a period of only 4.8 hours. Now, I haven't calculated how fast you have to go to complete Mars's orbit in 4.8 hours, but that's the size of that Wolf-Rayet star. Wolf-Rayet stars are some of the most massive, hottest, and most active stars that exist. This is known as Thor's Helmet, otherwise known as NGC 2359. And you're looking at multiple wavelengths here. This is narrow band filters. Not exactly sure what bands those are, but a very sharp image here of this nebular cloud with a Wolf-Rayet star at the middle. It's a blue supergiant, similar to Deneb, but perhaps without the Cygnus X3 little friend component. In any case, it's creating quite a molecularly interesting area there with lots of dense things happening. Anyway, that's the astronomy. That's the NASA astronomy picture of the day. You can find it yourself at apod.nasa.gov. Today's featured product is the Google Essential Shirt. Yes, Google defined. Please don't use Google as a verb unless it means to obtain biased information about someone or something on the World Wide Web. Allow me to use it in a sentence. I Googled it, and now I know less about it. And you can find that at our Redbubble shop. Links to that at the smAsho merch link at smashomash.com. You can also find this one. This is the smAsho store. And I would ask all of you cosmologists out there, are you safe yet? Anyway, welcome to the Neo-Renaissance. It's the headline on our homepage. If you go to smashomash.org, it will redirect you here. And again, visit our links. The smAsho forum has a cosmology forum. Go check that out if you like. You can also find our social media there. Cheers. Thanks to everybody who interacts. And welcome to the Neo-Renaissance. Also follow us on Twitter. We're 155 followers on Twitter and not even quite at 500 followers on Instagram. Shout out to Black Pill Radio. Anyway, Instagram.com/smashomash. It's not going to be cheap, fast, and good. It can either be good and fast but not cheap, cheap and fast but not good, or good and cheap but not fast. Today we're not picking any random numbers. We're talking about Centaurus A. So the featured story here for today's cosmology segment is about Centaurus A. So this is a small galaxy located at a pretty close distance to the Milky Way. And you can see how consistently variable this X-ray source is. It's a bit irregular here. No real pattern going on with that in terms of Centaurus A, the radio galaxy's outputs. There's the last 30 days. We saw one major transient outburst from it here about a little over 2 weeks ago there. And here's some more data on Centaurus A. So here it is in, well, geez, I don't know what wavelength it is. That's optical bands right there. And you can see the dust lanes there. This also has radio jets, and this is one of the first, if not the first, galaxy discovered to be a radio galaxy, an extragalactic radio source. So look at how differently this looks in UV. There are the structures associated with ultraviolet light. And you can see the sort of, you can see some evidence of like perhaps a spiral-shaped galactic disk here in the toroidal plane of this galaxy, Centaurus A. If we look at it in infrared, it looks completely different once again. It looks like an elliptical galaxy. And if you look at it in X-ray, it's a completely different structure once again. So there you go, some views of Centaurus A for you there. And you can look this object up if you like on the Neil Gehrels Swift-Bat X-ray Observatory. If you want to find it yourself and go look at it, go to the Neil Gehrels and type CEN space A. It's entry number 447. Anyway, an article about it recently came out here with some unprecedented detail of the inner portion of the jets. So this galaxy has galactic scale jets, and so a great article here about this. It's quite in depth, and it does quite a significant zoom into those jet features. And here's the paper. Here's some of the, let's click on full-size image here. There you go. There are some close-ups of that jet, and it's, yeah, it's spectacular. The latest about Centaurus A. There you can see the analysis of this in terms of brightness. And I don't want to get too in-depth into it on this video. That's today's Cosmology segment. Thanks for tuning in, by the way. I've been your host, Dan, a.k.a. smAsho, signing off from Smash News Network, least busted. Name and news.